Once again, welcome to dear students. In the last lecture, we had discussed the basic concepts of the optimization, and we had seen the basic concept of the powerful optimization method, that is a particle sum optimization. Now, in this lecture, we will see the detailed mathematics of a PSO, and we will try to solve a simple optimization sum using PSO. We will see the algorithm of PSO, and finally we will solve the optimization problem of power system using PSO method. Okay, so yesterday we had seen that the birds in the evening hours fly in a specific pattern to find the food source. Like, and there is a group leader which is known as the best particle or best bird. I would call this particle as a king particle because it is very near to the food source, right? Okay, so having known this fact, now we will see the basic concepts, basic basic concept of PSO, and then we will see the mathematical equations. Okay, so again, I will consider the two-dimensional system. It means this is x and this is y, and I assume that the solution I want to minimize. Yes, in optimization we want to either minimize or maximize a specific objective function, that is f of x, right? And we are interested in finding the optimum value of x star. We are interested in finding out x, right? So for particular optimization problem, there may be the number of feasible multiple solutions as per the definitions of the optimization. We will get the number of possible answers, right? And suppose this x value x star will give the minimum value of objective function f of x. This, so what is our aim? We start from the any point, we start from any random point, and then we will move here and there, here and there. We will travel, it means the bird will travel, in other words the particle will travel in this feasible region, in this feasible region, here and there, here and there, and ultimately this particle, this bird will reach to this final destination, to this final destination. This is our aim. Rather, this is the aim of any optimization algorithm. Okay, so yes, what is the first step in any optimization method? Step number one. Right. Okay, later on we will consider this sum. I want to minimize f of x is equal to x square plus 5x plus 10, and I want to find out the best value of x which will minimize this objective function. right? So see, this is a quadratic function because this function consists of x square, right? X square. So if you take the different values of x, and if you find the different corresponding different values of f of x, that is equal to y, right? If you put x is equal to 0, you will obtain some value of y, right? In this, put 0, so 0 square plus y into 0, 0, so you will get f of x is equal to 10, right? If you put x is equal to 1, then this is 1 square, so 1 plus 5 plus 10, 10 plus 5 plus 1, 16, right? If you put x is equal to minus 1, then it is minus 1 square, this is 1, 5 into minus 1, minus 5 plus 10, so 10 plus 1, 11, 11 minus 5, right? So we will get the answer. Similarly, put x is equal to minus 2, x is equal to minus 3, and you obtain the different values of y. And if you draw the graph of this f of x with respect, so on x-axis, this is plus x, this is minus x, here it is plus y, here it is minus y. So if you draw the graph of this f of x corresponding to different values of x, you will find that it will exist in the second quadrant, and it is a quadratic function. So our aim is to find out this x star, which minimize this function corresponding to this x star. The value of y is minimum. For any other x which is different from x star, suppose this is you call x2, the y value is higher than this minimized value. If you consider any other point, suppose this is x3, so this function value, y value, is more than this minimum value. Similarly, if you consider this x4, then this y value is obviously higher than the minimized optimized y value. So our aim is to find out x star using PSO. Okay. So as we had seen, the fact that the birds, it means particles, fly in the specific region to find out the food source, right? So I will select, let us say, three birds: bird number 1, bird number 2, and bird number 3. These three birds will fly in this region to find the food source. This is our concept. Now, as far as the PSO is concerned, what does this bird indicate? This particle indicate. Now onwards, I will use the word particle. I will not use the word bird. I will call it this as particle. So I consider this xy plane. Now what does this particle indicates? So particle is nothing but the x value, right? This particle has some x value, this, and it is also known as the possible solution. This is the possible solution of f of x. See, in any optimization, rather in any artificial intelligence method or computational intelligence method, in the first step, in the step number 1, we initialize the population of particles. And what particle indicates? When I say I have initialized one particle, it means I have initialized one x value randomly. X value randomly. I randomly initialize this value. There is no as such definite logic. This is the meaning of randomization. I randomly generate the particles x value, right? Suppose this value is, let us say this x value is 5. So this particle number 1, P1, P1's x value is 5. I have initialized this value randomly, right? Now next point. Yes, as per the rule, you have to initialize this randomized value between the particles minimum and maximum limit. Minimum and maximum limit. This is the rule. See, remember, in any optimization or engineering problem, each variable x has its minimum limit as well as maximum limit. If you consider the example of our human body, the heartbeats in the human body should exist between 70 to 90 pulse per minute, right? So if you consider the variable for heartbeat x, so its limit is 70 to 90. It means heartbeats variable should exist between 70 to 90. The x value should not fall below 70 or it should not exceed 90 value. This is the rule, right? So remember, every variable in engineering optimization problem has its minimum limit as well as its maximum limiter. Every variable has its minimum range and maximum range. In the literature, it is also written like, in the book you will find this word xl means lower limit and xu means upper limit. Similarly, symbolically, it is represented like x, and the lower part horizontal line is drawn, so it means it is a x lower limit, and x and a horizontal line is drawn on the top of the x. This is the upper limit, right? So every variable is initialized randomly within its permissible feasible range, within its permissible minimum and maximum value, right? Remember this point. Okay, now I create three particles as indicated below above. Let us say this is the particle P1, this is the particle P2, this is the particle P3, right? So in the first step we initialize the x values. So this is the x value of the particle P1, let us say it is x1. This is the initialized value of particle P2, let us say this is the x2, and this is the x value initialized for particle P3, this is x3, right? So these values are randomly generated within its feasible range. Okay. Now, as I told earlier, each particle will travel in the feasible space and ultimately it will try to reach to this optimum solution. It means every particle will updates its position value means x value in every iteration, and ultimately it will reach to the final solution. So now let us see it mathematically. So what is the mathematical equation? So for every particle P1, P2, P3, in this case we have considered only three possible solutions, three particle. So for every particle, let us write I means particle number. If I put I is equal to 1, then first particle, I is equal to 2, second particle, I is equal to 3 means third particle, right? So xi. Now see, every AI method or computational intelligence method or classical method, every optimization methods are the iterative methods, are the iterative methods. It means number of iterations are carried out in the simulation, and in every iteration we are updating our possible answers, we are updating our solutions, we are getting better and better answers, better and better solutions, sorry, better and better solutions in every iterations. And after doing a number of iterations which depends upon the size of the problem, we will obtain the final solutions. So we will start from the initial case and we will update the position. So xi of k plus 1, where k is the iteration number. So xik plus 1 is equal to xik plus step length, some step length, some step size or step length. So new position, how can we interpret this equation? New position of the particle in the k plus 1 iteration, it is equal to old position of the particle in the kth iteration. It means the old position of the particle in the previous iteration plus step length or step size. Every particle, let us say this is the initial position, it will take some step size, this is the step size, and ultimately it will reach to the new position. This is the new position, this is the old position. So new position is equal to old position plus something. This something is nothing but the step size. And you will find the more than 500 optimization algorithms, and every optimization algorithm has this common uh, criteria, you can say. But the difference is every optimization algorithm will have different equation of the step length or step size. And as you change the, if you propose a new equation of step length or step size, the new solution will change. So remember, every method will have different equation of step length or step size, but this equation is common for almost every AI or CI method, right? I think this is clear up to this point. Okay. Now, so again I draw the This is particle P1, particle P2 and particle P3, right? Now uh, let us say, okay, so first of all let us see how the PSO works, then we will convert this concept into the mathematical equations. But first of all let us try to see the concept here. As we seen, this is x1 is this is the x1, right? So for particle P1, initialization is x1, the variables x value is x1, right? Now corresponding to this value, initialize value of x, that is x1, find out the function value corresponding to x1. So find out f of x, that is y, right? And in a technical term, in mathematical term, this is known as the evaluation of the objective function, evaluation of the objective function or fitness function, or fitness function. We are evaluating, we are finding the value of objective function corresponding to our initialized solution, corresponding to our first particular's x value. So substitute this x value in the equation of f of x and you will get some y value, that is f of x1, right? Our equation was this x squared plus 5x plus 10. So we have initialized some x value, so replace x by that initialized value, you will obtain the y value. It means f of x value. This process is known as the evaluation of the objective function. Okay. Now the same procedure is carried out for the all particles, for the remaining particles. So for the corresponding to P2, the objective, the initialized x value is x2. So corresponding to P2, x2 is produced. So find out f of x2. So some scalar value will be obtained, f of x. Some scalar value, that means f of x will belong to R, real valued number which lies between minus infinity to plus infinity, except the imaginary part, right? So you will obtain some scalar value. Similarly for P3, we have initialized x3, this x3, and replace x3 in f of x, so you will obtain the function value that is a f of x3. Okay, right? So okay, now you have obtained these three function values, f of x1, f of x2 and f of x3. Now find out which particle gives minimum value of objective function, that is f of x. Hypothetically, see, I have not drawn this according to scale, so let us assume that among this and this value, f of x2 value is the smallest value among all these three f of x value, right? These are the f of x2 is the minimum value. So in this iteration, let us say this is the zeroth iteration. This is the zeroth iteration. At present, we are creating the base values. In the first iteration, then we will compare the values obtained with the values obtained in the zeroth iteration. Okay. So as f of x2 gives the minimum value, this in this iteration, in zeroth iteration, particle P2 is the best particle. It is considered as the best particle, or it is a king particle, or in the language of PSO, it is known as the global based particle. Global based particle. It is known as the G based particle. Why global based particle? Because this particle gives the minimum value of objective function among all particles. It is a king particle. It's a king. Okay. Now, okay. So now let us proceed further. Now, corresponding to now let us see another concepts also. Now, in this zeroth iteration, corresponding to this initial x value, initial position of the first particle, this initial position is also known as the personal personal based position, personal position or personal based position. See, as I told earlier, at present we are creating the base values. In the then subsequent iterations, we will compare the values obtained in the zeroth iteration with the first iteration. Then we will compare the values obtained in the second iteration with the first iteration, and so on. So in zeroth iteration, this x value is known as the personal based position, and it is written as p based personal based position. Position means x value. Please remember, position means x value, and p based I means for each particle number p1, p2, p3, p4, etc. So tell me, what is the personal based position value for the second particle? It is a p based 2, right? And in this case, it is how much? It is equal to x2. Similarly, what is the personal based position of the third particle? That is, x value is how much? P based, so it is x3. Personal based position means x value, so it is x3 in this case. Okay, so now using some equation, we will see that equation later on. Using some equation, we assume that the particle P1 has moved to the new position like this. This is the new position of particle P1, and this is the step length, and this is the new position. So particle P1, and I write like P1 superscript 1 means position of the first particle at the end of first iteration in the new iteration. This was the zeroth position value. This is the first iteration value. Similarly, I assume that particle P2 moves in this direction, and this is the new position of the particle P2 at the end of second iteration. Similarly, I assume that using some equation, P3 moves in this direction, and this is the new position of the particle P3 in the second iteration. Now repeat the same procedure which we did in the zeroth iteration. What we will do? We will find the we will evaluate the objective function again by substituting the x values in f of x. So again we will find f of x 1 corresponding to first particle at the end of first iteration. So f of x1 superscript 1, we will find out this value, we will obtain some scalar value. Similarly, in the function f of x, substitute x by x2 superscript 2, or this p2 superscript 2, or yes, you can write any. It means this is x2 superscript 2, right? This is the x value, and you will obtain some scalar function value, some scalar value which lies between minus infinity to plus infinity. Similarly, this is a p3 superscript 2, it means this is a x3 superscript 2, right? So evaluate the function by replacing x by x3 superscript 2. This is yes, this is the x3 value, this is the x3 superscript 2 value, right? So in f of x, replace x by x3 super, so you will obtain some scalar value. Now same procedure, among these three new obtained function values, find out which one is the minimum one, right? And now if you find that this function value in this first iteration is minimum, so in the first iteration this one is the G based particle, global based particle. This is the best of based particles, global based particle, because it gives minimum value of the objective function. So this is the G based which is obtained at the end of first iteration. Right, now compare this G based which is obtained in this iteration with the G based which you obtain in the 0th iteration. It means find out whether this function value is minimum or the function value corresponding to G based particle which was obtained in the 0th iteration is minimum. Which one is minimum, this one or this one? If this value is minimum, this value is minimum, then in the next iteration, the global based particle will be this and not this. So G based particle, this original G based particle will be replaced by this new G based particle, right? So in every iteration the G based particle, global based particle may change, and also each particle will follow this global based particle. Later on we will see the equations. At present I am just introducing the concept. Now the next concept is, it is regarding to the personal memory. It is also called as the personal intelligence. Again I draw the graph. This was P1 and this was a P1 at the iteration 1 and this is 0. Now this is the new position of the particle at the end of first iteration, right? Again, what was the x value corresponding to particle P1 at the end of 0th iteration? It was let us say uh, x0, right? And what is the x value of the particle p1 at the end of first iteration? That is, let us say, x1 superscript 1, right? This is x0 superscript 0. Okay. Now, in the new concept, in every iteration, every particle will compare its current position with the previous position. It means, see, in the previous case also we had obtained f of x corresponding to p10, right? So f of x0, we also evaluate f of x1 superscript 1, right? For the, let us say, this is the case for the first particle. We find, for the first particle, we find the function value at the end of 0th iteration. Similarly, we find the function value at the end of first iteration for the first particle, then for the second particle, and so on. So now we compare these function values, this and this one, and same concept, find out which one is minimum function value in these two iterations. So suppose you obtain that this function value is lesser than this one, f of x1 superscript 1 is less than f of x0 superscript 0. So this function value is better than, it is better than this value, this is higher than this is lower than this, so this is better than this, because we want to minimize the objective function. In every iteration, the function value should decrease, it should not increase, or at least it should maintain constant, or rather more specifically it should decrease. So this is the better answer. Okay, so always try to preserve the better answers. Okay, so in the subsequent iterations, in the second iteration, okay, so this is yes, this is the better answer. So what is the x value corresponding to this function value? So x value is x1 superscript 1. So this x1 superscript 1 is considered as the personal based position of the first particle at the end of first iteration, at the end of first iteration. Preserve this value, preserve this value. Why we preserve this value? Because in the subsequent iteration, the particle number 1 will try to follow this best position, and this concept is known as the personal memory concept or personal intelligence. Every particle will try to mimic, or every particle will try to follow the best position obtained till this particular iteration, right? The same procedure is carried out for the remaining particle number 2, 3, 4, etc., all the particles. It means all particles compare their position with the previously obtained position, and it will preserve the best position, which is corresponding to the minimum value of the objective function. So this is the another concept, right? And in this previous slide we had considered the concept of a g-based particle. So every particle will try to follow this g-based position, every particle will try to follow the king's position. And this concept in which the every particle follows the king particle is known as the group intelligence or group memory. Group intelligence or group memory or group memory. Okay. Okay, now let us see the third concept. Uh, okay. See, every particle, I have now considered only one particle, will go in this way, this way, this way, this way, this way. It will change its position, it will change its step length to finally reach to the optimum solution. Let us say this is the optimum solution. Okay, so suppose, so initially, what should be our logic? This is the particle's position. Now initially our step length should be high because we want to go to the far distance. I am trying to explain you the concept, right? So initial step length should be very high, and as you proceed towards the optimum solution, the step length should gradually decrease. Your step size should gradually decrease, and when you reach to the optimum solution, the step length should become almost zero because you have reached to the optimum solution, right? This is our logic. In initial phase, the step size or step length of the variable, particular particle or variable, should be high, and as you proceed, your step length should gradually decrease, and when you reach to the destination, the step length should become exactly zero, right? This is our concept. Now how can we consider in terms of mathematical equations and the concept, and that concept is related to the term inertia of the particle, inertia of the particle, and inertia constant, this inertia constant is designated as W. So in every iteration, the step length of particle is multiplied by a inertia constant, and this inertia constant is less than 1. It is a fraction, and it is less than 1, right? So initial value, let us say initial value is 0.9, and your step length is assume that it is 1. So what is the initial step length? It is 0.9, right? Now in the next phase, you decrease the inertia constant to 0.8, and assume that in this case also your step length is 1. I am hypothetically taking the example, right? So your step length will decrease 0.8, right? Then take the inertia constant as 0.7, step length is 1, so your step length will decrease 0.7, right? So typically we start the inertia constant from 0.9, and ultimately we up to the last iteration, it is gradually decreased by using specific formula. Later on we will say that formula, and ultimately it will reach to 0.3 or 0.2. So in the last iterations, the step length is multiplied by 0.3, 0.2. It means by a very small fraction, and ultimately what happens, the product of W and step length would be very less. It will be very less, and that we want. We want to reduce the step length as the number of iterations increases. So remember this concept. In initial phase, you may take higher step length, and as the number of iterations increases, the step length should be decreased, right? And we can use this equation W or omega into step length. Okay, so see, you cannot take a W higher than 1, because if I take 5, then every iteration the step length will be multiplied by a factor of 5, so step length will increase. We want to gradually decrease the step length. That's why we take omega as the fraction which is less than 1. And this concept is related to the inertia term. It is also called as the inertia term. In many algorithms, you will find this concept of inertia of the particle or inertia of the solution. Right? So we had seen these three concepts. Now we will see the mathematical formulation of PSO in which these three concepts are incorporated. Okay, so now the equations equations of PSO. So as we had discussed earlier, the new position of the x values of the particle I in the k plus 1 iteration is equal to xik, old position of the x value of the particle I in the previous iteration plus step length. And what is the equation of this step length? Now this step length is known as the velocity of the particle. Velocity of the particle. See, there is no relationship between the velocity concept which we had studied earlier in 12th standard, right? Because its unit is meter per second. In this case, there is no unit like meter per second. So don't correlate with that concept. In PSO, velocity means step length. Please remember, in the book you will find this word only, velocity, velocity of the particle. But when you read this word, then immediately you should recognize that it is the step length of the particle. So this was the old position, this is the new position of x. So new is equal to old plus this step length. So what is, how you will change the value of step length? So what is the equation of step length? And step length is designated as vi, velocity of the ith particle in the uh, kth iteration. So velocity of the ith particle. So it incorporates three concepts. Step length is composed of three equations. First equation is, we consider the inertia term, inertia of every particle. You will obtain some scalar value. You will obtain some scalar value plus personal memory of each particle, personal intelligence, or personal cognizance. This is also a suitable word. Personal memory of each particle. You will obtain again a scalar value plus group intelligence plus group memory or group intelligence. Again you will obtain the scalar value. So three scalar values are added and you will obtain the step length for each particle. This equation is to be applied for every particle. This is the meaning of for every particle. So if there are 5 particles, you will obtain 5 equations. If there are 100 particles, you will obtain 100 equations of step length. One equation corresponding to each particle, right? And one equation corresponding to one equation of xi, position updation. This equation is known as the updation of the position vector, position of the particle, right? So step for every particle. Okay, so these are the equations of PSO. Now let us see mathematically. It means, now yes, I draw a graph. So uh, this is the old position. Now old position plus this inertia term, then plus personal memory, then the group memory, this vector plus this vector plus this vector will give you the step length. This is Vi for every particle, right? And this step length Vi plus old position, this is the old position, Xik, this is Vi. So Vi plus Xik will give you this final position Xi of k plus 1. So this is the graphical representation, right? Okay, now let us see the equations. Yes, see this equation number 3 and equation number 4 are the equations of PSO. So how the velocity is updated? Velocity of the ith particle in k plus 1 iteration is equal to omega, it is the inertia weight, into the current velocity, current step size of the ith particle in kth iteration, plus C1 random 1 into personal based position of the ith particle minus current position of the ith particle in the kth iteration, plus C2 into random 2 into global based position of the global based particle minus current position of the ith particle in the kth iteration. So as we had discussed, W is the inertia weight, and using this equation, W max minus W minimum upon maximum number of iterations into the current iteration number, you can gradually decrease the omega from 0.9 to 0.3, right? Omega max is 0.9 and omega minimum is 0.3. Maximum number of iterations is problem specific. It may be 10,000, 1 lakh, 3 lakh. Okay, and C1 and C2 are the positive constants having the values lie between 0 to 2.5, and research has shown that C1 and C2 could be taken as 2.1, and you will get answer with sufficient accuracy. Now random 1 and random 2 both are the random numbers which are generated between 0 to 1, and this concept is known as the uniformly distributed random numbers which obeys the Gaussian curve. Now, so let us see these equations Vik plus 1. See the second equation. In second equation, what is this concept? We subtract the current position of the particle from the personal based position of that particle. It means the particle will try to follow its personal based position ever obtained till this iteration. And in this third equation, the current position of the particle, see this term and this term are same, current position of the particle is subtracted from the king particle. So current particle will try to follow the global based particle, And after obtaining the velocity of the particle is added to the current position of the particle to get the new position of the particle, and then the process continues. Now let us solve the sum to get the concept clear. Now in this case, I want to minimize the function f of x is equal to x square plus 5x plus 10, where x lies between minus infinity to plus infinity. As this objective function does not have any constraint equations, such type of problem is known as the unconstrained optimization problem. Okay, now uh, what is the first step? Initialize the population of particles. So you can consider any number of population of particles. In this case, I have considered 5 particles. You can take 10 particles, 20 particles, right? But in and for the large scale optimization problem, you can consider 100 particles. Generally, we don't consider more than 100 particles. So 100 particles is the final value, beyond which we don't consider. In this case, I will consider 5 particles. Okay, so so in the first step, initialize the particles. It means initialize the x values of the particles, and I call it as x superscript 0. So randomly initialize these values. So for first particle, I have considered minus 3.5. For second particle, I have considered minus 3.5. It means x value. For third, minus 2. For fourth, minus 1.5. For fifth, minus 1. You can consider the positive values as well. There is no problem. Your value should lie between minus infinity to plus infinity. So this is the first step. Now second step, initialize the step length or velocity v superscript 0. We have to initialize initial step length, of course. Yes. So what is the equation for initializing the velocity or step length of the particle? It is generally taken as 20% of upper bound minus lower bound. Upper bound minus lower bound. So every variable x has its maximum value x max minus x minimum. Suppose I consider x max 20 and my minimum value is minus 20, right? So 20 minus minus 20, so it is a 40, and 20% of 40, right? You will obtain the scalar value. So you can initialize the velocity at that value, But as it is a small scale problem, I have considered these values 0 0.05, 0 0.05, 0 0.05, 0.0. I have taken the same values. You can take the different values depending upon this equation. In this, I have not used this equation, right? But you can use this equation. So first step is the initialization of the population of the particle. This first step is common to all optimization method. Okay. Now, once you initialize these x values, find out the function values corresponding to each particle. And for simplicity in this case, I have assumed C1 and C2 as 1 and random numbers R1 and R2 as also 1. But practically this random number lies between 0 to 1, right? Now for the first particle, what is the x value? Minus 3.75. Replace this x value in f of x. So what is function? F means function, personal based value for the first particle at the end of 0th iteration. It is equal to what? x square plus 5x plus 10, x is minus 3.75 square plus 5 into x plus 10, so it is 5.31. Repeat the same procedure for the remaining particles. So functional personal based value for the second particle at the end of 0th iteration, x square plus 5x plus 10, x value is minus 3.5 plus 5 minus 3 plus 10, so it is 4.75. For third particle, the function value is 4. For the fourth, 4.75. Fifth, 6. Now this is the 0th iteration. We are creating the base case values. Now find which function value is minimum among these 5 available values. Tell me which one is the minimum. So minimum is this, fourth. So this third particle is the king particle or global based particle in the 0th iteration. Third particle. So yes, I call this third particle, and we consider its this third particle, it means its index means roll number of the particle. So 3 is the index of the base particle. This 3 is the base particle, so index is 3. Okay, what is the x value corresponding to third particle? X value is minus 2, so g based value is minus 2. G based means x value, and it is minus 2. And what is the function value? Fp, f means function value, fg based is 4. So in the 0th iteration, what is the best answer? Best answer is x value is minus 2, and corresponding to x value, best function value is 4, minimum value is 4, right? So we have created these base values. Now we will use the equations of velocity and step length to find the new position of every particle, right? We had seen this equation, Vik plus 1 is equal to 3, and fourth equation. Okay, now 0th iteration was complete. Now first iteration, right? So k is equal to 0. So k is equal to 0 means v1, I is equal to 1 for the first particle, v1 superscript 1, k is equal to 0, so it is 1. So step length of the first particle at the end of first iteration, it is equal to omega, I have considered 0.9, Vik, v1 superscript 0. So what was the velocity of the first particle in the 0th iteration? It was 0.05. 0.05 plus C1 1, R1 1, personal based position of the first particle. Okay, see, still there is a 0th iteration base case, right? So what is the personal based position of the particle? It is the same which we have initialized initially. In the 0th iteration, position is equal to personal based, because still we don't have any two values using which we can carry out the comparison, right? So the personal based position, it means x value of the first particle is this, p based is minus 3.75. In the subsequent iterations it will get changed. So p based, personal based position of the first particle is minus 3.75 minus, what is the current position of the particle? Current position, it means x1 superscript 0, x1 superscript 0, it is again minus 3.75, both are same, minus 3.75 plus C2R2 1 into 1 minus into bracket g based, it means x value of the global based particle, x value, what is global based? This is the global based, in its x value, not function value, remember, x value is minus 2. X value is minus 2. See, in this equation you have to consider the X values. Remember, I repeat, consider the X values, not function values. So G best is minus 2 minus Xik. See, this term and this term both are same. So minus 3.75 minus 3.75. So you will obtain 1.795. It's the step length of the first particle. So new position of the first particle x1 superscript 1, it is equal to x10 x sorry x uh, yes, x1 superscript 0, k is equal to 0, and for the first particle it is minus 3.75 plus lambda. It is a constriction factor, it is a constant, later on we will see this factor, into vi v11 is a 1.795. So you will obtain new position of the first particle at the end of first iteration as minus 3.2115. This is the new value of x for the first particle. Now use the same equations number 3 and 4 for the remaining remaining 4 particles, and find out the velocity and positions of all particles, and I have tabulated in this. So at the end of iteration 1, the updated position, that is so we obtain the updated positions, it means current position of every particle, that is x1, which are obtained from the these equations, right? And updated velocity, that is v superscript 1 for every particle, and they are tabulated like this for every particle. Okay, so now using these updated positions of x values, obtain the function values. Now the procedure gets repeated, right? So iteration number 2 and k is 1, using the updated position x superscript 1, find the fitness of each particle. Okay, so fp based 1 at the end of first iteration, that is x1 superscript 1 square plus 5 x1 superscript 1 plus 10, right? So functional personal based value of the first particle at the end of first iteration is this is the x value minus 3.211 square plus 5 minus 3 plus 10. So value obtained is 4.2562. I have not mentioned other equations. I have done this work in notebook, so you can cross check these values. So for the second particle 4.03, for the third 4.01, fourth 4.49, fifth 6.94. Okay, so now in this iteration, which function value is the minimum out of these 5 values? This one is the minimum. 4.0136 is the minimum value of function among all particles. So this is the global best particle in this iteration. Yes, this is the global best particle. And what is the corresponding function value? This is a fp based. So now we consider this as a global based. So it is fg based, and it is 4.0136. Okay, now these are the values which we obtain in the first iteration. These values should be compared with the values which are obtained in the 0th iteration. Now we will compare these values with the 0th iteration, and we will update the global based particle in real sense. Okay, so see the results of the first 0th iteration. These are the results of the 0th iteration, and in that case what was the G based function, G based value? It was 4. And now in this case, the functional FG based value is 4.01. So function value is improved or deproved. We want to minimize the function value. So in every iteration, function value should decrease. So in this case, what happened? The function value corresponding to global based particle is increased. So it is deproved, right? So what is our conclusion? What is the G based particle at the end of first iteration? G based particle should be this one, because it still holds the minimum value of the objective function, that is 4. So now in the subsequent iteration, this particle will act as the global based particle and not the global based particle which we obtain in the first iteration. So new FG based is 4, and corresponding to this FG based, which is equal to 4, what is X value? X value is G based, and G based is -2. So in subsequent, in the third iteration, in the next iteration rather, we will consider G based as -2. G based is -2. One point is certain, right? Now, yes, I have made the table for our understanding. So I have in the first column particle number 1, 2, 3, 4, 5. Now corresponding to the zeroth iteration, functional personal based value, function value at k is equal to 0, and this is the position value. So for first particle, function value was this 5.31, X value was this. Now these two columns are corresponding to the function value corresponding to the k is equal to 1, and X value corresponding to first iteration. So it is 4.2 and X value is -3.25. Okay, so now we will carry out two comparisons. We will compare this 1, 2, 3, 4, fourth column and the first column, and we will find which one is minimum, and we will preserve the minimum one. We will preserve the minimum one, and it will be used in the subsequent iteration, right? So see, we are comparing uh, this function value, this and this. Which one is minimum? This one is minimum. 4.25 is minimum. So new FP based, new function personal based value is 4.2562, and corresponding to this new based function personal based value, what is X? X is this -3.2115. So new P based, new personal based position, it means X value for the particle number 1 is -3.2115. So in the next iteration for P based, remember the second, this P based, in the second term, P based will be considered as this -3.2115, right? And current position will be subtracted from the new P based position. It means every particle tries to minimize the distance between its current position to the personal based position ever obtained till this iteration. So this is the P based for the first particle. Same procedure for the remaining particles. Yes, tell me for the second particle 4.75, 4.03, which one is better? This one is better. And which, so corresponding to this, which X? This X should be taken. So this X, so it is what? P based to personal based X value. Now third particle 4 and 4.01. Which one is best? This one is best. This one is best, not this one. For the third particle, there is no improvement. So preserve this one. So in the next iteration, what is functional personal base? 4. And corresponding to 4, what is x? X value is -2. So for the third particle, what is p based? It is -2, -2. Similarly, for the fourth, this one is better. And for the fifth, this and this one is better. Okay, so tell me, what is the personal best for this particle? This one or this one? This one corresponding to this, so -1, -1, right? And okay, now among these newly obtained best function values, which one is minimum? This one is minimum. So in subsequent iteration, functional G based value based of FP based global based particle will be function value will be 4, and corresponding G based value x value would be -2. Okay, so now let us use hmm, okay, so new velocity of the first particle at the end of second iteration would be equal to 0.9 into v1 superscript 1. We obtain this value. This is the v1 superscript 1, right? 1.795 plus c1 r111. Personal p based one, yes, what was the p based one? -3.2115. Okay, and what is x1 superscript 1, right? X1, it means current position of the particle, it is -3.2115, right? Plus c2 r2 1, g based is -2. We have obtained this, g based is -2, right? Minus current position of the first particle. So this term and this term are same, so this and this are same, so it is 2.827. And similarly find out the new position of the second particle, that is equal to x1 superscript 1 plus lambda v1. This is not a square, this is superscript 2, right? So new velocity, new step length, which is just obtained. So x1 superscript 2 is equal to current position x11 plus 0.3 into this 2.8, so minus 2.3634. So this is the updated x value of the first particle at the end of second iteration, right? Same procedure is carried out for the remaining particles, right? See, there is a special for the third particle, right? V32 omega V31 0.9 0.045 C1 R1. Yes, P base 3. What is the P based 3 for the third particle? It is -2, minus current position of the third particle. Current position of the third particle is this -1.98, -1.98, -1.9. See the difference, right? Plus C2 R211. G based is -2. Okay, minus current position of the third particle, it is what? -1.98, minus 1.98. So you obtain this value, and ultimately you can obtain the x32. Similarly, for the fourth particle, you can cross check these equations, right? For the fourth particle, what is the current value? Minus 1.63. And what is the p based value? It is also minus 1.63, right? Minus 1.63 minus 1.63. G based is minus 2, right? So these are the positions at the end of second iterations. These are the velocities at the end of second iterations. Now repeat the same procedure for the iteration 3, right? So in this iteration, the global based particles x position will change. Now global based, see these are the function value: 3.76, 3.78, 4.01, 4.14, 6.22. Lowest one is 3.76. So in the previous iteration, third particle was the global based, but now the global based is changed and the first particle is the global based. So index of the global based particle is 1, roll number is 1, right? And corresponding to this g functional value, what is the x value? X value you obtain is minus 2.36. This is the base value at the end of third iteration, right? And I have made the table, and you can carry out the further iterations. You can cross check your answers. Okay, so in the next iteration, the global based particle will change, as well as the new functional personal based values will also change. I would recommend you to do the hand calculation for this third iteration, and try to compare these values with which you obtain, and it will give you lots of confidence as far as PSO is concerned. So this procedure is repeated for a number of times, right? These are the values at the end of third iteration, right? I have listed all the values. So I run these algorithms for 500 iterations or 10,000 iterations or 1 lakh iterations, right? And ultimately you will obtain the G based value. It means X value will be equal to minus 2.5, and corresponding to G based value, the functional G based value, functional value corresponding to the G based particle is obtained as 3.75. So these are the optimum answers obtained by the PSO algorithm. So this is the working of PSO, right? In the next lecture, we will solve the optimization problem of power system using PSO method.